Hi everyone! In this short video, we cover 5 common number system conversions. So we have binary to decimal, decimal to binary, decimal to octal, decimal to hexadecimal, and hexadecimal to binary. So for each one, I define the system, show a work example, and explain why every step works. So you understand it, not just memorize. So what is binary? Binary is a way of writing numbers using only two digits, 0 and 1. It's called the base 2 number system because each position in a binary number represents a power of 2, unlike decimal, which is base 10 and uses 0 to 9. In binary, the value of each place doubles as you move left. 2 squared to 0 is equal to 1. 2 squared to 1 is equal to 2. 2 squared to 2 is equal to 4. 2 squared to 3 is equal to 8, and so on. So, this is the example of binary to decimal. Una, isusulat natin yung binary number ng 1, 0, 1, 1. At imumultiply natin silang lahat sa 2. Ngayon, ilagay natin yung place values. Ito ay 2 raised to the power ng position. Magsisimula tayo sa ibaba. So, 2 squared to 0, 2 squared to 1, 2 squared to 2, and 2 squared to 3. Mumultiply natin lahat ng bawat digit sa place value niya. So, 1 times 2 squared to 3 equals 8. And 0 times 2 squared to 2 equals 0. Then 1 times 2 squared to 1 equals 2. And 1 times 2 squared to 0 equals 1. Bakit 1? Kasi only number raised to 0 is always 1. Pagkatapos, i-add natin lahat ng mga ito. So, 8 plus 2 is 10 plus 1 equals 11. So, binary 1, 0, 1, 1 equals decimal 11. Ito ang answer. Next, decimal to binary conversion. Decimal numbers are in base 10, meaning they use the digits 0 to 9. Binary numbers are in base 2, which only uses 0 and 1. To convert a decimal number to binary, we repeatedly divide the number by 2 and write down the remainder each time. Once the quotient becomes 0, we read the remainders from bottom to top. That gives us the binary number. It is the example of decimal to binary. For example, let's convert 13 to binary. So, 13 divided by 2 is 6. Remainder 1. Then, 6 divided by 2 is equal to 3. Remainder 0. And 3 divided by 2 is equal 1. Remainder 1. Then 1 divided by 2 is equal to 0. Remainder 1. Now, read the remainder from the last to the point. 1 1, 0, 1. So the decimal number 13 is 1101. So this is the final answer. To convert a decimal number to binary, we divide the number by 2 because binary is base 2. Each division step gives a remainder of 0 or 1, which becomes a binary digit. We keep dividing by 2 until the quotient is 0, then read the remainders from bottom to top to get the binary number. For example, 13 divided by 2 gives remainder 101 and 1, which in reverse order is 1101. So next, decimal to octal. Decimal numbers are in base 10, meaning they use digits 0 to 9. Octal numbers are in base 8, using digits 0 to 7. Now, let's talk about converting a decimal to octal. So, divide 100 by 8. We get 5 with a remainder of 5. Then, divide 5 by 8. So, we get 0 with a remainder of 5. So, 100 is decimal is 55 in octal. Why 55? Because reading from the bottom to top, and that's 55 in octal. That's how you convert decimal to octal. Just keep dividing by 8 and write the remainders in reverse order. To convert from decimal to octal, we divide the decimal number by 8 repeatedly and write down the remainders. Once we get the 0, we read the remainders from bottom to top to form the octal number. Next, decimal to hexadecimal conversion. Now, let's talk about how to convert a decimal number, which is base 10, into hexadecimal, which is base 16. The decimal system uses digits 0 to 9, while hexadecimal uses 0 to 9 and the letters A to F. So, this is the example of decimal to hexadecimal. So, convert natin ang 26 to hexadecimal. So, divide 26 by 16. So, we get 1 with a remainder of 10. So, yung 10 sa hexadecimal ay A. Yung quotient na 1 ay mas mababa na sa 16. Kaya iyon ang unang digit natin. So, ang 26 sa decimal ay 1A sa hexadecimal. So, we divided by 16 because hexadecimal is base 16. So, we need to see how many 16 fit into the decimal number. The remainder becomes a digit in the hexadecimal number. So, it's important to write it down. We repeat the process with the quotient to get the next digits until it becomes 0. We write the remainders from bottom to top because the first remainder is actually the last digit in the hexadecimal number. And the last one is hexadecimal to binary. It's simple because every hex digit directly matches a 4-bit binary number. Hexadecimal is base 16, meaning it has digits from 0 to 9 and letters A to F. So, there is an example of hexadecimal to binary. For example, if we have hexadecimal 2F. The digit 2 becomes 0, 0, 1, 0 in binary. And the letter F becomes 1, 1, 1, 1 in binary. Then, put them together and to get 0, 0, 1, 0, 1, 1, 0. So, the hexadecimal 2F equals binary 0, 0, 1, 0, 1, 1, 1, 1. So, this is the answer. Hexadecimal to binary conversion works by replacing each hex digit with its 4-bit binary equivalent because one hex digit 0 to F represents values 0 to 15, which fit perfectly into 4 binary bits. We convert each digit separately to avoid mistakes, then combine the binary groups to get the final answer. For example, in hex 2F, 2 becomes 0010 and F becomes 1111. So the binary result is 00101111.